Welcome to Algorithm video series. In the previous tutorial, we discussed lower bound binary search using the classic method where we store the index and continue searching. Now, in this video, we'll use the same approach to implement upper bound binary search. First, let's understand what upper bound means. Upper bound is the index of the first element that is strictly greater than the given target element. Input is a sorted list and a target element. Output is the first position where element is strictly greater than the target element. For example, if I take target as 30, then here output is 7th index. That is, when target is 30, we need to ignore all the numbers smaller than or equal to the target element. Here 10 is smaller than 30, 20 is smaller than 30, 30 is equal to 30. So we need to ignore all the numbers which are smaller than or equal to the target element. Then here 40 is greater than 30. This is the first position where element is strictly greater than the target element. So this is our output. If target is 25, here 10 is smaller than 25, 20 is smaller than 25, 30 is greater than 25. This is the first position in this sorted list where element is greater than the target element. So this is our upper bound index. To solve this problem, I'll use binary search algorithm. But here we'll modify the binary search algorithm. We'll use classic method where we store the index and continue searching. Previously, we discussed upper bound problem. In that, we used modified binary search algorithm to solve that problem. That is the one of the way to solve this problem. Here we are discussing another method. This method is more simpler and similar to normal binary search algorithm. In normal binary search, what we'll do? Start by defining your search space. That is, we'll take two pointers, low and high. Low will point to the first element and high will point to the last element, right? Next, we'll find the middle element using low plus high truncated division 2 formula. Then we'll compare the middle element and the target element. There are three possibilities. Mid element is equal to target element. Then we'll return the index. Mid element is less than target. Then we'll search in the right side. We'll take low equal to mid plus 1. And mid element is greater than target element. Then we'll search in the left side, high equal to mid minus 1. This is the normal binary search algorithm. Here we want to find the first position where element is strictly greater than the target element. For that, what we need to do is, first step, start by defining your search space. So we'll take low equal to 0, high equal to length of list minus 1. That is, we'll point low to the first element and high to the last element of the list. Same as normal binary search. Then we'll find the middle element. We'll use the same formula, low plus high truncated division 2. Then we'll compare the middle element and target element. Here we need to consider only two possibilities. One is when element is smaller than or equal to the target element. Another one is when element is greater than target element. Here, if elements are smaller than or equal to the target element, we need to ignore them, right? Here we want to find the first position where element is greater than the target element. So, the elements which are smaller than or equal to the target elements are ignored here. If middle element is less than or equal to target element, that means all the elements present in the left side of the middle element is also less than or equal to the target element. Because here input is a sorted list. We are using list where numbers are sorted in ascending order. So here we need to ignore all the smaller number or numbers equal to the target element. So that's why when middle element is less than or equal to target element, we need to search in the right side. For that, we need to take pointer low equal to mid plus 1. If middle element is less than or equal to target element, just ignore them. So search in the right side. Okay, so the next case is when middle element is greater than target element. So what we need to do when middle element is greater than target element? Here our aim is to find the element which are strictly greater than the target element, right? Here we found an element which is greater than target element. So it can be one of our possible answer. Why it is one of the possible answer? Because here we are not searching the elements in the sequential order. We are using binary search algorithm. Because of that, we don't know this element is the very first element where element is greater than the target element. Here we got a position where element is greater than the target element. Whether this one is the first position, we don't know. In the upper bound problem, we want to find the first position where element is greater than the target element. So to find that, we need to continue search in the left side. Why left side? That is because if I want first position or first occurrence, we need to search in the left side in the sorted list. Okay. So here first take a variable and store this index. Index is here mid. Okay. Continue search in the left side. So for that you need to take high equal to mid minus 1. Why save the index? Because here we found an element which is greater than the target element. So it can be one of the possible answer. Then why search in the left side? Because we found an element which is greater than the target element, but we don't know that is the first element in the list where element is greater than the target element. Here we want first position where element is greater than the target element. To find that first position, we need to continue search in the left side. Let's take an example. Let's take target as 25. First, let's define the search space low and high. Then find the middle element. So here this is mid index, that is 3, and this is middle element. Now compare the middle element and target element. Here element is greater than the target element. Now we found an element which is greater than the target element. Now what we need to do? This index can be one of the possible answer, right? Because here element is greater than the target element. So I'll store that index. Take a variable and store that index. Now next, we need to continue search in the left side. Here now high equal to mid minus 1. This is our high. This is our search area now. Then again apply modified binary search algorithm. Here low plus high truncated division 2. So this is our mid. Compare mid and target element. Here element is less than the target element. When element is less than target element, we need to ignore that element. So we need to search in the right side of the middle element. So low equal to mid plus 1. So now this is our search area. Find the middle element. Low plus high truncated division 2. So we'll get this. Compare 20 and 25. Here 20 is smaller than the 25. So what we need to do? We need to search in the right side of the middle element. Low becomes mid plus 1. Now here you can see low is greater than high. In the binary search algorithm, when low is greater than high, we need to stop. So we got answer as 3. Let me take 15. This is low, this is high. Find the middle element. Compare the middle element and target. Here this element is greater than the target element, one of the possible answers. So store the index. Then search in the left side. Find the middle element. 20 and 15. 20 is greater than 15 now. This can be the first position where element is strictly greater than the target element. So store this index now. We don't want previous index. Store this latest index now. Answer is 1. And continue search in the left side. So here this becomes high. Again find the middle element. 10 and 15. Here 10 is smaller. Element is smaller, so search in the right side. Low is mid plus 1. Now here low is greater than high. When low is greater than high, we need to stop. This is our answer. Let's take target as 30. This is mid. Compare middle element and target element. It is equal. When element is smaller than or equal to middle element, we need to ignore left side and we need to search in the right side. So here low becomes mid plus 1. So now this is our search area. Find the middle element. This is middle element, right? 30 and 30 equal. So search in the right side. Now find the middle element. 30 and 30 equal. So search in the right side. Low equal to mid plus 1. Find middle element. 40 is greater than 30. So we need to take this as one of the possible answer. So store that index and search in the left side. To search in the left side, we need to take high equal to mid minus 1. So now here you can see low is greater than high. We need to stop. This is our answer. Now what about target as 50, which is greater than all the elements in this list? Here mid element and target element. Middle element is smaller. So search in the right side. Middle element and target element. Here middle element is smaller. So search in the right side. Again find the middle element and target. Here element is smaller than the target, so search in the right side. Again middle element and target. Here target is greater, so search in the right side. So here low equal to mid plus 1. Now here you can see low is greater than high. What to do in this situation? Here whenever middle element becomes greater than the target element, we'll store that index in a variable, right? So initially I'll take its value as length of list. Default value for this variable is length of list. So here in this situation you can see in every comparison element is smaller than the target element. So answer equal to mid is never executed. That's why we'll take default value for this variable, that is length of list. Here length of list is 8. So we'll get 8 in this situation. So upper bound index for target 50 in this list is 8th index. To solve this scenario gracefully, we'll take default value for this variable as length of list. If we found a position where element is strictly greater than the target element, then we'll replace this value. We'll upgrade this value. So this is about example. Next, let's write the program. Okay, here we have a lower bound program. I'll give you the link of this video in the description box. Now we want to write upper bound program. I'll keep the function name as binary search. You can take upper bound also. Low equal to 0, high equal to length of numbers minus 1. This is the 2 pointers to define search space. Next here we'll take a variable to save the index of the element when element is strictly greater than the target element. Initially I'll take its value as length of numbers. Then low is less than or equal to high. This is the loop condition for normal binary search. Then find the middle element. Then compare numbers of mid is less than or equal to target element. If middle element is less than or equal to target element, ignore those elements, search in the right side, that's why low equal to mid plus 1. Else, here else part will execute when middle element is strictly greater than the target element. That time what we need to do, we need to save that index and we need to search in the left side. And lastly, we need to return answer. Okay, next here inputs, target, and we need to call the binary search. It is for upper bound. Here we need to take a variable to store the result, and here we need to print upper bound index. Save and execute. Let's take 5 elements, numbers in ascending order. Let's enter 60. So 5. Enter 6. Let's enter 2. Index 3. Okay. So this is how we can solve upper bound problem using another method. Okay, so that's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.